guided notes. We're trying to finish this year off. We got the exponents, and if we can get to it, we'll do the Pythagorean theorem. So we learned that an exponent is produced by multiplying some base or some number by itself several times. Like this would be 3 multiplied by itself 5 times. The 3 is called the base, the 5 is called the exponent. When you multiply powers with the same base, all you need to do is add the exponents together. So if we look at our first example here, we got 2 to the first, 2 to the first. So 2 to the first times 2 to the first would be 2 to the second. And x to the second times x to the third would be x to the fifth. And if we wanted to simplify it a little bit further, 2 to the second could be written as 4 x to the fifth. It just depends on what you're asked to do in a particular problem. Okay, if we have one that's got multiple parts to it, then we just kind of separate it out by putting the numbers or the coefficients together. Then we put all of the powers together. So u to the 9th and u to the 9th. Then y to the 3rd and y to the 1st. 2 times 4 is 8. 3 times 8 is 24. 9 plus 9 is 18. And 3 plus 1 is 4. So that would be that particular expression simplified. Pretty straightforward, right? Okay. When we divide powers with the same base, we subtract the exponents. And if we have numbers involved in the expression, we just simplify the fraction on the numbers. So, like this one. Now when we talk about subtracting the exponents, we take the smaller exponent and subtract it from the bigger one, wherever it's going to keep it positive. So in this first one, we would go v to the 4 minus 2 power, which would equal v to the second power. On this next one, 35 over 7 simplifies, or 5 simplifies to be 7. Then on our v's, we would go on the bottom we would have v to the first power, because there's one more v on the bottom than there is on the top. And on the w's, we would subtract 3 from the bottom as well, and we end up with w to the first on the bottom, because we subtracted the smaller one from the bigger one. All right, now some people may like it better if we just expand it out. On the top, we have 4 v's and 3 w's, right? On the bottom, we have 5 v's, 1, 2, 3, 4, 5, and 4 w's. So now when we cancel 1 off the top and the bottom for each one, that leaves us 1 v and 1 w on the bottom, and then our 7 on the top. So that's another way to do those kind of problems. All right, then another power we had, or rule that we had, was whenever you raise a power to a power, you just multiply the exponents. So this one would just then end up being 4 times 3, which would be 4 to the 12th power. This would be 4 times 2, which would be 8, so y to the 8th power. This one we'd have 2 times 2 and 2 times 3, so that would be x to the 4th power, y to the 6th power. On this one, we actually have a negative 2 out here. We got to keep in mind there's a power of 1 on that one, so this 5 exponent gets multiplied by each of the exponents on the inside. So negative 2 to the 5th, w to the 5th, u to the 10th. And then it says to simplify. So what would negative 2 to the 5th be? Well, you have an odd number of negatives, and then you'd have 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. So this would be negative 32 w to the 5th, u to the 10th. So depending on what form they want their answer in, that's what you'd end up with. Okay, then we learned about the zero exponent rule. We found out that anything to the 0 power except for 0 is equal to 1. So 5 to the 0 power, 1. Negative 89 to the 0 power, 1. 36,439 to the 0 power, yep, you guessed it, 1. 7x to the 0 power, that also equals 1. Now, there could be other numbers involved here, but as long as it's raised to the 0 power, it will eventually, everything would cancel out or disappear, leaving you behind with just the number 1. Then we went on to the negative exponent rule. We found out that if you have a negative exponent, to make it positive, you move it up or down across the fraction bar. So like if I have something to a negative power, I just move the exponent to the bottom, make it positive, and leave a 1 in its wake on top. Or on this particular problem, we've got a negative on the top and on the bottom, so I'm just going to switch places with those two numbers and make them positive, following that negative exponent rule. And now I can subtract the smaller one from the bigger one, so I'm going to subtract 6 off of the bottom. And when I do it off the top, I end up with y to the 0 power over y to the 3rd power. And we know that anything to the 0 power is just equal to 1. So 1 over y to the 3rd power. Okay, on this one, we've got a negative exponent on the top, so we're going to move it down to the bottom and make it positive. Now we can follow our rules. We have 4n to the 3rd. So I'm going to write it up here, 4n to the 3rd over m to the 8th n to the 2nd. And I know I can subtract that 2 from the 3 on the top, the smaller one from the bigger one. So that's going to leave me for a final answer of 4n to the 1st all over m to the 8th power. All right, so here's an expression to simplify, and we're going to use all the rules that we can think of to help us. So 4 over 3, that part is simplified, right? How about u to the 0? Anything to the 0 power equals 1. So I'm going to put a 1 right there. All right, on the bottom I have a v. On the top I have a v to the minus 1. So I'm going to move that negative exponent to the bottom. And that cancels it off the top. This negative exponent I have down here, I'm going to move to the top. And now I can look at what I have left. So on the top, I'll still have that u squared. And on the bottom, I will have v to the 1st times v to the 1st, which is v to the 2nd. So when we finally simplify it, 4 times 1 is 4. 4u squared over 3v squared is my final simplified expression. So today we're going to do the scientific notation review. So to do that, we find out that when you have a number, especially a great big number or a really small number, you can make it more usable by moving the decimal and writing the number as a power of 10. So if the exponent is negative, move the decimal point to the left. And if the exponent is positive, move the decimal place to the right to get the number back into standard form. So like this number has been written in scientific notation. So now we're going to move the decimal 4 places to the left, and then if necessary add some zeros in there. And there we go. That's the number that was in standard form before we started out. This one, we're going to move the decimal 5 places to the right. So after that 9, we're going to do 4 more. That means we got to add 4 zeros, right? 1, 2, 3, 4. So that's taking a number that is in scientific notation and moving it back to standard notation. Okay, to take out of standard form and into scientific notation form, you move the decimal until there's only one digit, non-zero digit to the left of it. So 1, 2, 3, 4, 5, 6, 7. So this would be 4.25. Then we moved it 7 places to the right, Moved it 7 places, the decimal. So then that means we're going to multiply by 10 and have a exponent of -7. Now if the decimal starts to the right, then the exponent will be positive. So let's see how that works. It looks like the exponent is right, or the decimal is right here, so we're actually going to move it to the left. 1, 2, 3, 4, 5. So this is going to be 5.4 times 10. We had to move it 1, 2, 3, 4, 5 places. And this next one, 1, 2, 3, 4, 5. So 7.96 times 10 to the -5 power. All right. Then we went on to multiplying numbers in scientific notation. So in that case, you multiply the front digits. So 4 times 3.8. If I do that on my calculator, 4 times 3.8 is 15.2. So 15.2. Then you multiply that by 10, and you add the exponents, -3 plus 5. -3 plus -5. That would make that a -8. But we got to move the decimal one more place to the left to get this back into scientific notation. So this should be 1.52 times 10. And we have to add 1 when we move the exponent to the left. So this would be times 10 to the -7 power. All right, and then we talked about dividing exponents with the same base. So to do that, we divide the two coefficients. So 5.4 divided by 9 is actually 0.6. And then we subtract the bottom exponent from the top one. So that ends up being -2 plus 5. So that would be 0.6 times 10 to the third power. But then we have to move the decimal over so we have a one non-zero digit. And when we do that, we have to subtract 1 from the exponent. So that gives us 2. All right, so on our next one, we're going to do 8.3 divided by 8.2. 8.3 divided by 8.2. Then that ends up being 1.01 times 10. And 2 minus 4 is, we're going to subtract the bottom from the top. That gives us a -2 power. So that makes it a pretty small number, doesn't it? Okay, very good. All right, so that gives us Alex number 116. And that'll just about wrap it up because testing starts on Monday. Maybe a couple of classes will get Pythagorean theorem in before we start the test. But good luck. Thank you very much.